Voice of Industry.
Voice of Industries.
Daniel, welcome to Voice of Industries. I'm very happy to have you today here to discuss about digitization in large manufacturing companies and to exchange with you about your experience at Capgemini. First, could you introduce yourself and your activity at Capgemini?
Sure. Thank you very much, Mathieu, for having me today. I'm a digital manufacturing director within the Intelligent Operations COE at Capgemini Engineering, and I'm leading the manufacturing intelligence offering, the purpose of which is to leverage data and digital solutions to improve the industrial performance of our customers.
Great. Let's go directly into the main challenge that industrial companies face when approaching this topic of digitization. So what is their challenge when they contact you about this topic?
There are many challenges, both organizational and technical challenges. The organizational part is usually linked to the fact that they don't always have a good knowledge of their current Industry 4.0 maturity. So they don't know how ready they are for the transformation to Industry 4.0 use cases, for instance. And that is often combined with a lack of knowledge about or lack of clear ambitions, what it is that they want to achieve. And that's only the organizational part of it. And then comes the technical challenges. The architecture that they have in their manufacturing operations, the landscape of IT/OT systems is not always suitable to provide the data sets which will bring the benefits through the data-centric use cases or streamlined scheduling and planning processes, for instance, or tracking performance at the right level with the right granularity. So they have all kinds of processes and challenges to match. They've got this issue about data and the knowledge of the data they have, how they can use it, how they can collect it, how they can process it. They have challenges about who is responsible for what data, for what system, so that you can interconnect the systems and make those separate systems a complete, let's say, meta system that is going to drive the performance that you need.
What I understand is despite the development of Industry 4.0, many companies still struggle to implement the use of data in their plants. In your experience, what are the main mistakes companies make when they are attempting to digitize their plants?
The biggest mistakes they do is that they tend to consider those projects as IT projects, whereas indeed those projects are IT, OT, data science combined projects. So you need to approach that with a holistic view of what you want to achieve and the fact that you would need a combination of skills to get the value out of your data and out of your, let's say, smart systems or Industry 4.0 systems. The other mistake they sometimes make is that they believe that just doing a proof of value or a proof of concept, which is focused only on technical feasibility, will bring the benefits they are expecting. The reason for this is that once you've proven you can achieve something technically, if you don't have the business case to turn that into a real scale-up project, you will stop there. And they're ending up quite often in what we call a POC, proof of concept purgatory, where they've got lots of initiatives, none of them being really scaled up and providing the enterprise-wide benefits they were supposed to bring.
What I understand from what you said is that the approach today failed to bring together the need from operational teams and I would say all the technical aspects of the digitization in the plant. So based on your experience, what are the good recipe? What is a good recipe to achieve that?
There are half a dozen success factors. First of all, it needs to be driven by the business. So you need to have a business ambition for a need for a solution. You're not starting from the solution. You're starting from the need, and that has to be therefore a program or a transformation that is business driven. It can be jointly managed or jointly governed by IT, OT, and business people, but there needs to be a business purpose to that. And the second key success factor is kind of acculturation or education of the whole teams, the whole ecosystem about what can be achieved. Quite often, people are not aware of what can be achieved and how easy it can be to achieve using the right solutions, using the right, sometimes off-the-shelf solution. And they tend to think about very advanced solutions or very advanced technologies without having in mind that using more mundane, more common technologies could bring very, very good value and solve their problems. So that they look at, things which are complex, not knowing exactly how they're going to manage that, whereas they could be having first steps which are going to provide value, build momentum, align business, IT, and OT people behind this value they've been creating. Our experience has shown, for instance, that only visualization, proper visualization, is bringing benefits, which you would not suspect. But having proper OE visualization, near real time, well contextualized, is going to allow you to gain a few points of OE, which is a considerable amount of money in any big factory. So acculturation, business-driven operations, multidisciplinary teams. That's key. If you're having this project, you need to have IT, you need to have cybersecurity people because you're going to process sensitive data. You want to make them exposed in a safe way. You need to have IT for infrastructure. You need to have OT for the knowledge of the data coming, or business people, but usually the OT people know where the data resides in the control systems, and the business people will know what meaning those data have. So it's really a multidisciplinary team that you need to set up. If you go from one type of people in the team, that is not going to work. And if you're looking at data scientists and involved in the project, for instance, when you want to leverage data for the more advanced use cases, you need to have a specific brand or specific type of data scientist people. You need to have people with business knowledge, which is not often the case when you look at data scientists. They are more coming from the big data world, and here we need people who understand physics, who understand chemistry, who understand mechanical design problems.
As you just mentioned, digital transformation often requires many ingredients, like deploying new software, new solution, new architectures, but also to change the organization, methodology, so to summarize, change management. If we look this from the eyes of a CIO, what are their current expectations on that?
Usually they think about systems rather than organizations. So they think about solutions they're going to buy, solutions they're going to get developed and rolled out. And I was just having that conversation right 10 minutes ago. But a point that the SVP of operations made was that without the proper converged IT-OT organization, where we have clear roles and responsibilities, and IT is able to help the OT organization and the deployment of OT solutions, there's no way you're going to get something that is sustainably providing the benefits you're expecting. So you really have to think about a converged IT-OT organization, possibly thinking about having a center of expertise where people coming from the business will be working in close cooperation with people from IT and OT. That is the technical specialist, I would say. You need to have those business people be in the same team as a product owner, as people seconded for a temporary amount of time, or people being there permanently, but you need to bring that business knowledge into the team, even for the development team. So it's basically having a product owner.
You just mentioned the question of make or buy, which is often at stake when discussing digitization projects. What is your experience and recommendation on that aspect?
My experience, my recommendation is it's not one or the other. It's both combined. It is quite typical to see the ability to reach and get very significant benefits from off-the-shelf solutions that you can implement very quickly, especially if you're talking cloud, if you're talking SaaS solutions. And at the same time, there's always going to be a few very specific one-off needs that require specific algorithms or specific solutions to be developed. So it's not I'm going to go for off-the-shelf or I'm going to go for bespoke all the time. I could use off-the-shelf as an accelerator, covering 80% of my needs, and I will have a small team of dedicated, very high-end developers, data scientists, doing the job that needs to be done once to solve a very specific problem, or doing a very business-specific algorithm that can't be found, reasonably found in an off-the-shelf product because the market for it would be too narrow.
As I understand, speed and acceleration is one of the topics.
Yeah.
And because I would say industrials want to have a return on investment, and so the faster it is, the better it is. On top of off-the-shelf solution, do you have any other aspects that can accelerate this digital transformation?
Modularization of business processes. If you want to deploy an end-to-end solution, let's talk, for instance, of an MES. Let's not talk about data science, but just an MES. If you want to deploy a standard MES over all your manufacturing processes, because there's value in doing so, each manufacturing process, if you look at it end-to-end, will be specific to one production line or one building in a site. So you may have a very large diversity. If you break down your manufacturing process into archetypes like I've got continuous, I've got batch, I've got assembly, then you start having building blocks that can be replicated across your entire footprint. So thinking about business process harmonization is going to bring you acceleration, especially if you go into modular building blocks for your business process. And it's also going to be about your organization. If you start thinking about having a COE that is combining the IT, data science, and business skills, delivering use cases for the business, you can go fast because you will have a sustainable operating model that's going to be delivering value very quickly to the operations, bringing the funding for more use cases. And that's going to be a snowball effect, basically. That's what we've seen at our customers. Get the first big payback on one lighthouse use case. That's going to trigger momentum, trigger savings, which is going to provide the budget for more use cases.
I know you advocate for the idea of Center of Expertise, so COE, to support digital transformation in the field, in the plant. Could you elaborate a bit on this concept?
Yep, sure. The idea of this Center of Excellence is to bring together a team of, if we're talking about data-centric use cases, a team of data engineers, a couple data scientists, business people with expertise of the process that we want to optimize, and have them work together as a single team. The reason for this to work well is that it will allow you to quickly spin up a team for a dedicated use case. If you don't have this, let's say, service delivery model, what happens is that you're creating a new project for every use case, meaning it takes some time. If you don't have the resources, you will have to go to find resources externally. Whereas if you have a service delivery center that is combining the three main disciplines that are needed to deliver value, the people are always there. You can submit your use case as a token for them. They're processing it. They've got the business knowledge because the business people coming from production, coming from operations are part of the team. It's not a hierarchical organization, it's a functional organization. Therefore, having this kind of organization, you have people who are always ready and you're managing your backlog of use case rather than creating one-off projects. We've seen that with our customers. We've created service delivery centers for our customers when they needed to have both agility, knowledge, maintenance over time, and the best productivity for the developments. That's how it works.
Could you drive us through one example of a project that you did for an industrial company in order to explain to us the way you helped them going through this process?
Absolutely. Best case scenario for us is when we start from the beginning with our customers. That is, we help them define their ambition, or we start from the ambition they have. It is that is just defining how they want their factory of the future to work, how they want this factory of the future to behave, what is the operating model for that, and what are the overarching goals they have. So if we can start from that point, it is, I would say, for us, the best situation. The reason for it is that if we have this information from the beginning, we have the freedom to explore all possible use cases and prioritize them according to whether or not they are contributing to the ambition. That is the starting point. So we're building a roadmap of use cases. So what are the business problems? What are the business issues that I want to solve? What are the technologies that can help me solve those problems? And from there, we define two things. We define the kind of architecture and the kind of tools that should be implemented to solve the business problems. And we can define the organization. So we have an idea of the operating model. If we want a plant to be a smart plant that is operating almost autonomously for certain type of business processes, that's defining what kind of means, what kind of IT, OT solutions, what kind of operating model you want to implement. And then we define those operating models. We scope the use cases. Next stage is we implement the use cases, we demonstrate the value, and we industrialize the use cases, we industrialize the solutions, and scale them up. So we manage to scale up as well. So it's an end-to-end package that we're proposing, and that we like to do because that's where you get the most benefits. The approach can also be, if there is a portfolio of use case that has already been defined, we can just implement those, bringing some later on some project management methodology to ensure that the scale-up is efficient and fast. That is industrializing the way you manage your project, your scale-up, but the way you industrialize your solution. Again, it is very important. If you've got the proper architecture and the proper business process breakdown, you can replicate your solutions. You can replicate your use cases, and that means that you are saving on the development cost and maximizing value, because being fast in scaling up your use cases will bring the benefits earlier for you as an organization.
Scale up, I think, is one of the difficulties for these large manufacturing companies. I think you agree with that?
Absolutely.
So do you have some tips or experience that can secure the scale up and ensure that it's done efficiently?
Yeah, it's one of the key success factors which I mentioned already. Your initiatives must be business driven, and whatever you do as a pilot or proof of concept stage needs to be analyzed in terms of what kind of benefits it is providing. So if again you're doing a proof of concept, you're doing a pilot implementation, and it is just there to demonstrate that you can technically achieve what you wanted to achieve, it will stay there. It will not fly. It will not scale up, because you're just missing two important parts in the goals that a good pilot or a good proof of concept should include. You need to include, during the proof of concept phase, the design of your scale-up. So the proof of concept solution or the scope of the proof of concept may be limited, but while you are doing it, you should be thinking about, how should I change my solution? How should I industrialize it so that it can be applicable to my complete industrial footprint? So you need to start small, but think big. That as simple as that. And so that when the proof of concept is a success, you're ready to scale up. What happens usually is that you've got a technically successful proof of concept, but since you don't know at this moment when you realize that it is a success, you don't know how to scale up, it's going to stop. The momentum you've built will decrease, and it's going to stop. And it will stop also if during the proof of concept, you're not refining your business benefits analysis. You're not refining your business case, because you will need the funding. At the end of the proof of concept, if you want to go for scale up, you need to know, what are the resources I need? How much is it going to cost? What is my project plan? If that is not included, if those things are not included as deliverables as part of your proof of concept, you will end up with something that is, a nice technical success, and it will not scale up because you just don't know how to scale it up.
Could you give us a few examples of use cases you worked on and the benefit for your customers?
Oh, yeah. So roughly, and that's because also I'm focusing on manufacturing intelligence, the use cases I've been working on and scaling are basically three kinds. I'm going to give you three examples. I've been working on predictive quality. using a well-known solution. And that has brought some very significant benefits. Once we had the data, and I was mentioning that data availability was always a challenge, but once we had the data, we were able, in a matter of weeks, doing influence analysis, and I guess you know what kind of solution I'm talking about, using influence analysis, we were able to figure out manufacturing settings which were impacting the occurrence or creating the occurrence of defects on a semi-finished good. And the customer was losing €1 million a year due to the scrap of those semi-finished goods. We are able to reduce the level of scrap by more than 50%, saving 500K a year. This is significant money. And that was applicable to 4 sites at the time. So we were talking about €2 million that could be saved per year after using a smart analytics solution for a few weeks. So that is one. The other one is predictive maintenance. Again, if you're looking at how industrial performance is usually measured and represented, we're talking OEE, we're talking overall equipment effectiveness. And 2 parts to it, 2 main parts is, am I producing quality at rate? And do I have enough availability of my manufacturing equipment to produce as much as I would like during a certain period of time? So predictive maintenance is about reducing maintenance cost. It's about increasing availability of your production assets, and that's what we did for our customers using, I would say, advanced but not rocket science models. We're still able to save 540K a year on a certain type of equipment. They had 19 units of those equipment in that site. They are now scaling up across the tens of similar equipments they've got across their 20 sites. And the last one is one that I like especially because it is smart. It is very smart, and I can say so because the initial design is coming from the customer, so I can feel comfortable saying that it is very smart. What we did is we industrialized a solution, the purpose of which was to override the built-in control loops of HVAC units to make that control loop more energy efficient. So it's a sustainability use case as well. They're saving 20%. Thanks to that, they're saving 20% on their electricity bills. It is interesting because the way it's being done means that you're doing the difficult part only once. That is, you're updating the HVAC control unit only once. And there's a lot of diversity, and these are OT systems, and this is very complex and challenging, but you're doing it only once. And you're combining traditional OT technologies with modern cloud-based technologies where we have the smart algorithms running in the cloud, which brings some, let's say, scale-up speed, which brings some cheaper management of the different versions, ability to test and deploy very quickly new versions. And we're talking, thanks to that use case, something about like 20% reductions on the electricity bills, on the energy bills, which is a significant amount of money. We're talking €1 million a year here, plus CO2 footprint reduction.
One thing I was surprised in what you said is it seems that you want to keep it simple. In order to succeed, to go step by step, first starting with use cases that are not so complex but that will bring a good return on investment, and then go a step further, and even on the AI side, to start with things that are already known and easy to implement and that can bring value quickly to the customer.
Yes, definitely. And the thing is not to tackle simple problem, but it's to keep it simple in the way you're tackling them. You need to tackle problems that have immediate value. You need to demonstrate the value in a very clear way in a short amount of time. So that may be a complex problem to solve, like the one I was referring to for predictive quality previously, but you need to solve it in a very limited amount of time, because that's how you're going to create the momentum and the drive for the funding and basically accelerate that whole transformation. You also need to keep it simple in terms of solutions. So you may not have 10,000 data scientists in your organization, but you might have 10,000 operators. In a large industrial company, you may have that number. And the idea, and the keep it simple, is keep it simple at different levels so that operators can leverage a bit of the power or a significant bit of the power of Industry 4.0 solutions, and that the solution should be catering to different categories of people, providing different features so that each one in the organization can leverage a bit of that power, data-driven power that we have now available.
Can I summarize what we discussed by first think value and identify use case with real value before starting any proof of concept or MVP? Secondly, since the beginning, think about scaling up. And finally, what I understood from your previous answer is having a widespread use of data within the organization.
Yeah, absolutely. You're totally right. These are the three main items to be mentioned. It's think about scale up, go for the value, and provide services and features to the complete organization, because that's how you're going to maximize your benefits and make everyone happy, by the way. I've seen operators jumping on the new capabilities of the solutions that were offered to them.
Thank you, Daniel, for sharing your experience in digitization in large industrial companies. It was really rich with many insights on how to go a step further. Thank you.
Thank you very much, Mathieu. A pleasure to be there.